Adding and subtracting like radicals is pretty simple. This is very much the same idea as combining like terms. So remember, when we look for like terms, they have to be the same variable to the same exponent. So when I combine radicals, like radicals would have to have the same index and the same radicand. So if we look at these examples down here, we're going to look for those two things. Now think back to when we added like terms. If I had something like 1x plus 7x, those are like terms, and we can combine those and get 8x. That is almost the exact same problem as number 1. So we check two things. Same index? Yes. Same radicand? Yes. So that means that we can go ahead and add these. I have 1 right here, and I have 7 right here. So 1 fourth root of 10 plus 7 fourth roots of 10 gives me altogether 8 fourth roots of 10. And that's the end. So see if you can kind of do number 2 in your head before you listen to me. Excuse me. So we have 5 square roots of w plus 3 square roots of w. That's going to give us 8 square roots of w. Now, if you look at number 3, you might say, well, we can't do that one because the radicands don't match, which is true at this point. But what we need to do then is check to see if we can simplify any of these, which might then allow us to end up with the same base. We're working with third roots, so look at your perfect cubes column, and we see that 27 goes into 54. So 27 times 2 gives us 54. 27 is the perfect cube. So the cube root of 27 is 3. That can come out. But 2 has to stay in. Then we have minus the cube root of 2 because that doesn't simplify any. And then when we look at perfect cubes again with 24, that's going to be 8 times 3. The cube root of 8 is 2. And then we have the 3 left still inside. Go ahead and maybe put this on pause and see if you can try number 4 on your own. It's the exact same idea. Then come on back. So we want to go ahead and try to simplify each of these first. Remember, these are square roots since there's nothing written there. So the square root of 9 would give me 3. Then 2 goes into 5 twice with 1 left over. So I have 3w squared times the square root of w. Minus, we already have that 1w there, so then we're going to multiply it by whatever we get. That w I just wrote is the one that was there to start with. So now we say 2 goes into 3 once with 1 left over. And now we need to multiply here to simplify. So these two go together. I get 3w squared square root of w minus w squared times the square root of w. When variables are involved, here's where we have to be very careful. Not only do we need to have like radicals, which in this case we do have, but we also have to have like terms. Otherwise, we can't combine those. A w squared can only add to a w squared, etc. So 3w squared minus w squared would give me 2w squared times the square root of w. And that's it. You're all done. Simplify first, then combine any of the ones that match. Oh, I didn't finish number 3. So this is kind of important. These two you can combine together because they both have a cube root of 2. This guy doesn't match, so he's going to stay the same. So the only thing we can do here is we get 2 times the cube root of 2, and then we add 2 times the cube root of 3. And so that would be our final answer. Sorry, I put the video on pause so I could cough, and then I must have started a new problem instead of finishing the one I was on. Anyway, now you know. See you later.